Okay, so let's start about today's class. So am I audible to everyone, right?
Yes, ma'am.
Okay.
Yes, yes.
Okay, so let's start today's class. I am sharing my screen at first, and after that I will tell. Okay, can you see the screen?
Yes.
Okay. So today I will talk about the previous year assignment 3, that means week 3 questions. And but before going to that, I want to tell you one thing that I think I have given some homework to all of you in the previous class. So have you checked that? Like I told you, writer's function, sum primes L, that takes as input a list of integers L and returns the sum of all the prime numbers in L. So that was the previous week's homework type thing. So did anyone do that? Or should I go on that at first? I think there is no one who did. Have anyone done that? Okay. So is there is no reply, so that means I can go with that one at first, and after that we can go in the next one. So what is the thing basically? The question is write a function. The function will be with the name of some primes and bracket L, and that takes as a input a list of integers L and returns the sum of all the prime numbers in L. So this is the question. So basically what we should do at first, we should find any number that is prime or not, we have to check at first, and after that if it is prime then we can sum that. Otherwise if it is not a prime number then we totally ignore that one. So this is the main thing we will have to do. So at first what we will do, at first the main theme for us will be for checking the number, whatever we are taking, this number is prime or not. That is the first work, and the second work will be that that prime number, if it is prime number then it can add to our sum primes L, I mean sum primes function, or otherwise we can leave it. So these two operations we can do simultaneously in this program. So I have written that program a little bit already, so I can just go to that program and there I will explain about that program. So can you see the screen? This is the program here. So what is the program basically meaning? So you can see here that program is yes. The program is basically divided in 3 parts. So what are the parts? The first part is basically sum primes, whatever we are going to do at the final position. And the second one is the factors of A. And the third one is the is prime. Is prime is nothing but you can write any type of name there. So what the total program is doing, I am taking first of all this one. Let's say here the factors. So factors of n, as you already know that how to calculate the factor of n. So if n can be any type of number. So if let's say n is, let's say very simple 5. Okay. So then factor list is empty, that is it is the initialization of that factor list. Then I am going to do a for loop. For loop is for I in range 1 to n plus 1. So 1 to n plus 1 means basically it will go from 1 to n, because it's 1, 2, 3, 4 up to n. So that means I will give the value like I will be 1, 2, 3, 4, 5. here in this case, because I have taken n equals to 5. Okay, so now I will check one if condition. If condition is for obviously that the factor of the production of that factor. So if n percentage of I equals 0, that means obviously that n is totally divisible by I, then we can write factor list equals to factor list plus I. That means we can add that factor list, and the new factor list will be the factor list plus I, and then return factor list. It's a very simple programming about the factor or calculation. So up to this program we can find what is the value of the factor of n, I mean the factor of 5. So here in our case the factor of 5 will be like 1 and 5, because 5 is a prime number, so obviously there will be only 1 and 5. Now coming to the isprime function. So what it is showing? It is showing that if isprime is true or not, it is a Boolean function you can write here. So if isprime is n, that means like if isprime n is a prime number, then we can add this in our session here in the sometimes n. If it is not a Boolean, if it is not a prime number, that means if it is a false one in Boolean function, then it can't go to the sometime n. So here in sometime n, what I am going at first, I can do my initialization here again. That initialization. Okay. Now then again for loop range 0 to length of n, that means n minus like 0 to n basically. So and then if isprime is true, that means sum equals to sum of L of I. If it is not true, then we can't add that sum to that sum equals to sum plus L. So this is the whole program, and it's a very simple program. So let's run that program, right? So what I will do here, I am just going to open a terminal, as you already know all these things. And then I am going to write Python 3. Then what? 11. Okay. So from 11 import start. Okay. So now what was that programming? Yeah. There L is a list of numbers, some numbers. Okay. So L is a list of some numbers. That means let's say N equals to, I'm just writing here 3, 4, whatever. I'm just going to write anything. Right? Then sometimes L. Okay. So sometimes L is giving us a number here. Okay. Let's check at first. What will be the value of, let's say n equals to 6. Then factors, you can see that it is giving us all the factors of 6. That means the factors of n is 1, 2, 3 and 6. Now coming to the isprime. 6. So isprime 6 is false. That means 6 is not a prime number. If it is a prime number, then it will show a true value. Let's say n equals to 5, as I already told you in that example. So factors, let's say 5. Then it is 1 and 5. Now isprime, let's say 5. It's true. That means 5 is a prime number. Okay. Now coming to the next one, the sum prime. Sometimes, okay, so that means I'm just going here 3, 4, 5, 6, 2, whatever. Then sometimes it's 10. Why it is 10? See here 3 is a prime number, 4 is not a prime number, 5 is a prime number, and 6 is not a prime number, 2 is also a prime number. So that means 3 plus 5 plus 2, that means 10. So it's giving the prime number calculation, I mean the summation of all the prime number in our list.
Ma'am?
Yes.
Ma'am, can we write the function factor and isprime above some prime and some prime
Yes.
below that?
Yeah, obviously we can do like that. Okay, I'm doing that one also, right?
Ma'am, once you kindly explain is prime, ma'am.
Yes. Okay, just let me check had a problem here. Right now you were this one you were talking,
Yes,
right?
ma'am.
Okay. Now I am going to save that. And one more problem I had, but okay, I will let you know after that. Can you see the screen, or should I increase a little bit?
Yes, ma'am, can see.
Okay. Or otherwise I can just clear all these things at first. Yeah, I think I should increase that one. Yes. So, oh, sorry. From 11 port start. Okay, so now, okay, the problem was that if I write these things above of that sometimes, then it will work or not. Okay, so let's check n equals to again some numbers, this type of numbers. Okay, 10. Okay, now some primes. So is it working? Obviously working, because 3 and 2 both are prime number, and there is no other prime number, so 3 plus 2 is equal to 5. So that means the Python has a very advantage thing that whatever you are writing here I mean, it is not like that if I will write some prime behind, late of these factors and is prime, it is not working, or if I write some prime is above of the factors and is prime, it will not work. It will work, no problem on that. Okay, that sequence, there is no problem on that. And okay, now there is a question about that is prime, right? So is prime, what it will do? Is prime is nothing but a Boolean function. Okay, so is prime is telling us about the prime numbers, about the, I mean that if it is prime number or it is not a prime number. So if it is a prime number, then it will tell us a true value. True and false, basically you know that it's a Boolean expression. So it is telling us about one number, is it prime number or it is not prime. So if let's say is prime 9, then it will give us false. And if I am writing here is prime, let's say 7, then it will give us true. So it's a Boolean function which will tell us about the type of that number. Is it prime number or is it not? Is it a composite number? So these things, this definition, these two lines is basically telling us about that.
Ma'am, is it a Boolean, ma'am? Is prime is no, sorry. Is it a built-in?
Yeah, is it a built-in means you can see here that I am just writing here definition is prime n, then I am writing here return factors n, 1 and n. So if it is a true, I mean you can say like that, if this is prime n is true, then factors of n will be 1 and n. Oh my god, that is the sound coming.
Yes, got madam clearly. Got it clearly. Just one small question. What thing is that you are importing from 11 star? What
What? Sorry?
for what purpose that is used import from 11 star? For what purpose that is there?
Kanchan, can you please unmute? Can you please
From
mute
11
yourself?
import.
Yeah, just a minute, I'm coming. Yes, yeah, tell me. From 11 import?
What is that? I see.
Okay. Okay. Did you not attend before 2 classes? Okay, whatever. So,
No.
okay, no problem, no problem. Okay, so what is basically this one? Let's say I'm just writing here Python 3. So if I write here Python 3, that means I am going inside of the Python 3 interpreter. Okay, so here you can see that that sign has already changed. If I write here Python 3, then it is just giving us the sign which says that I am inside of that interpreter. Okay, now what I will do, as I have written that program outside of that interpreter, I have just written somewhere else in some folder and all this. I have written that type of program outside of that interpreter, so I have to call that program inside of our interpreter. So for that I can write here from and then file name. Let's say file name is 11. I have written here 11.py, so that means file name is 11. So from 11 then import star. So star is basically nothing but I'm just telling them to copy all the things whatever it is written in 11.py inside our interpreter. So if I write this then they can understand, okay, I mean the Python interpreter can understand what is 11.py, and after that we can write whatever we want from that 11.py program. Okay.
So that means that is user defined 11 file is there. That's not built-in file.
No, we are giving that name. If I write
Okay.
here 11.1.py, then we have to write here
Okay.
11.1.py.
User defined. Okay.
11.1 from 11.1 import star. Okay.
Previously, I thought that it is version number or like that.
No.
Updated version number or like that.
No. Because I'm just calling this file in our interpreter. Okay.
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 Ma'am, one more doubt, ma'am. In is prime, the second statement, ma'am, I have doubt in second statement. Here you have taken return factors of n double equal to 1 comma n. Are we doing a comparison here? Because I missed the last class.
Sorry, what?
Are we doing any comparison here?
No. Double equals is nothing but the same as mathematical equals. Okay. So double, there is no comparison. And comparison means like you can say like it is a logical operation. That means equals means factor a, factors a, whatever it will be, we can write it is as equals to 1 and n. Another number and then 1. If it is a prime number, because you know that if prime number is there, that means only two factors will be there, 1 and the number itself. So that means that if is prime n is true, that means we have to write factors n equals to 1 and n. This equal is nothing but the mathematical equal. It's a very simple equal. And if I am writing that type of equal, then it's different from that mathematical equal. I think I have already mentioned what the difference between say double equal and single equal in Python. But yeah, I mean in this case double equal is nothing but the mathematical equals. And we are just going to write if is prime is true, that means our factors n will be 1 and itself that number. Okay. Okay, so we can go to the next question, I think. As previously in previous class, some of you already told me about to explain about that week 3 previous year as well as week 3 this year questions. So I have written. Yes.
Last week PDF is not on link. I'm not getting the link of your last week PDF.
That same link, that whatever it is in that drive link you had, right? Before I sent you in that chat box in Google Meet, one drive link. So that same link you can just go and you can find it that week 2 PDF as well as week 1 PDF.
Oh, okay, thank you, ma'am.
If you don't have it, then I can also give you right now. But okay, I will give you. Just remind me after this. I mean, at the very last of that class, and I will give you that link also. Okay.
Ma'am, one more, ma'am.
Yes.
Can we get these videos, ma'am, the explanation videos, because I missed one class of yours.
Yes, you can just have that. You just search in Google, YouTube, my name. Then you can directly find these videos there.
Thank you.
Okay. And one more thing, previously in that first class also, so many students were asking me about that other TA's video link, how can I get that? So I have copied that link here, I can share with you. Yes, this one is the link. So this is the TA, another TA, okay? So who is taking yesterday's class? That means each Saturday he is taking class from 3 to 5. So I can share with you that link also, so that you can have that thing.
Thank you.
This is a link.
On the link can be
Yes.
where from that link you provided is accessible, or you can see from that link where you are sending that.
Which one?
That link just you have shown now. Link for your that classes.
Yes,
This,
I
recording
have.
of this
Yes, I have sent here right now only that chat box. You can see the chat box, right?
chat box. Okay.
Yes, you can see the chat box. In that chat
Okay.
box, in that message section, I have sent you a link. This is
Okay.
the link of that previous PA, that Arun Prakash. Okay.
Thank you.
And
Ma'am, but there are no videos on that channel.
no videos. How can it possible? Oh,
Yes. No
Yeah, I
videos.
think the videos are private or something.
I can see, but right now I can't see.
Yeah. Yes, ma'am. Now itself I clicked and I checked it. They are saying no videos in that.
But I checked. Okay, let me check. Okay. I checked there before. Okay, just a minute. I can give you the link right now. Yes, this is the link. Arun Prakash.
The screen we can get from our assignment down. We can get this link. You take them.
Yeah, it's showing there. Okay, I can share this link. Just a minute. Can you see that link? Just open that link. Mine, okay. Offset. Yes. So this is the first class.
So it's ma'am, it's working now.
Yes. So this is the first class, and you can just go to that list and you can find another class. And stay on this. Okay. So now coming to the next class, next question. So you can find with the
Ma'am,
yes.
ma'am, in this problem, in some prime problem,
Hmm.
can we use append in place of concatenation? We can use append method also.
Okay. Okay. You are talking about this line, right?
Yes, ma'am.
Okay. Let's check, right?
No, F factor list dot append I.
Yeah. This one,
Yeah,
right?
it's not here.
Yes, ma'am.
See what it is showing.
No, ma'am, only factor list dot append I, not factor list equal to.
Yeah. Sorry. Fine.
Okay, ma'am.
So it's also working because append is nothing but just writing here something equals to something plus I, and okay, there is a difference between something equals to something plus I and factor list dot append I. Have you seen that SAR's lecture? There he already told about the difference between append dot append I and that something equals to something plus I, in concatenation. So I think you have already heard that difference. Basically, what is the difference here? If I write here factor list dot append I, that is fine. Okay, now if I write here, let's say factor equals to factor list. Factor list. Okay. So now, sorry, equals to. Okay. So if it is like that, and the indentation will be here like that is. So if it is like that, then if I write here fact equals to what, then it will show us the fact which is exactly equal to the factor list. So that means the new factor list will be go to the as a factorial. Okay, but if I write here factor list equal to factor list plus I, then what happened? Then this new factor list will not be stored as factor here. Okay, so this is a simple difference, but as there is, in that problem there is no like something equals to something before of that calculation. If there is nothing, then we can write here something concatenation as well as the append. It is same for that program. Okay, so I think.
When should you use concatenation or addition symbol?
Sorry, hello?
When should we use append or addition symbol?
Yes, see. Yeah, Sir already told about that whatever I am just telling right now. Let's say here I am writing here fact equals to factor list. Okay, now here factor list equals to, I have just writing here factor list plus I. So what it will happen? It will happen that new factor list, this is the
after the assigning you are using your appending, so the fact is not getting the new
yeah. So if in my program at later stage fact fact will be needed, then we can have that fact. But if I write like that as a concatenation factor list equals to factor list plus I, then our fact will not be the same as factor list. Okay, the fact will be the previous one.
If we use append, that will change.
No, so it's totally depend on your programming, what you want in that programming, right? So if in your program factor FACT should be factor list, the new factor list it should be, then we can write as a something dot I, that factor list dot append I. If we don't need that same copy of that factor list as fact, then we can write like that here, whatever it is written here.
If we give append, then the old list can be changed.
Yes, it's a
addition symbol. The old list would be the same. The new list would be in the factor list.
Yes, here factor list is nothing but the new factor list.
Okay.
If I write here new like that, but it is not good. So it is the new one, and the fact will not be this. In that case, fact will not be the new one. So if according to your programming, what you need, you just write here if it is append or it is a concatenation. So it's totally depend on your program, what you want in that program.
Okay.
So in here, as there is no equal sign, that we are not comparing anything here, so I am just writing here something plus I, or as well as something dot append I. Okay, now coming to the second question. So the second question is a previous year week 3 assignment. Okay, so here you can see one question that write a function contracting M. This is the name of the function, contracting M, that takes as input a list of integer L and returns true if the absolute difference between each adjacent pair of elements strictly decreases. So I think it is not that much clearly understandable right now. Just see here that line absolute, it will return true if the absolute difference between each adjacent pair of elements strictly decreases. Let's say I am here writing here 1. I am here writing 1, 2, 3, 4, 5. Okay, so this is a list I'm talking about. Now what it is showing us, if I write here contracting of L, then what it will show, true or false. So what it is saying, 1 and 2, it is a adjacent pair, right? So the difference between 1 and 2, what is the difference between 1 and 2? It is 1. And 2 and 3, what is the difference between this? 1. All the things have got, adjacent pair has a difference 1. So it will show as false, because that each adjacent pair of elements are not strictly decreasing. Now let's say I am writing here 2, 10, 5, 3. This is my n. So what is the meaning? So 8 and 2 and 10, what is the difference between this? 8. 10 and 5, what is the difference? 5. 5 and 3, what is the difference? 2. So that means that difference is chronologically decreasing. That means its elements are strictly decreases. So if my L is like that, 2, 10, 5, 3, then it will give us true value. Can you understand the question?
Yes, ma'am. Here, what is the meaning of contracting means?
Yeah, it's a factor name, like whatever I can write in that name, right? So
Function name.
yeah, for function. It is the function name. So contracting L, you can write anything. So your name L, that is also possible. Okay. So the main thing, what is I just want to go to tell you that what is the meaning of that question. The question's meaning is like, if I write here 5, 2, 1, this is the list, then what it will tell? Is it telling true or is it telling false?
True.
True.
Because it is decreasing, strictly decreasing.
Okay, so what is the difference between that? 3 and this one? 1. So that means it's strictly decreasing. That is true. And
Yes.
if it is like that, then our programming should give us the contracting L will be true. Okay. And let's say this one. 2 minus 1, 5, 20. What it will give?
False.
False.
False, ma'am.
Okay, and one more thing, yes, and one more thing about that minus 1, I mean the negative number. Let's say I am writing here that type of things. Minus 1, yes, this one. So what it should give?
True.
True.
True, ma'am.
Yes, because the difference and this difference is decreasing. Okay,
Yes,
now,
ma'am.
yes, now coming to the program here, what will be the program for that? So can you please, can you understand what will be the program? It will be only 2 or 3 line program, because the program is nothing but with that difference. Okay, so let's say this is, okay, let's say here some numbers 3, 2, 5, 10. I am writing it like that. Okay. So here, if I write that position, that means 0, 1, 2, 3, right? So L of 1 minus L of 0 should be greater than L of 2 minus L of 1. Right? If it is like that, if the condition will be true, and not only for this one, it should be for all other combination. Whatever is the adjacent pair, it should be that rule should be followed, and if that type of rule will be followed, then we can say L is a true, that contracting L will be true. Right, so only one line needed in our program that L of 1 minus L of 0 of that ABS value. Okay, I mean that absolute value. This should be greater than ABS of L of 2 minus L of 1. Okay, so this condition should be satisfied, as well as I can write here that recurrence relation, that L of, let's say, 0 to L minus 1. I can show you that program. So this recurrence condition will give us each and every condition should be satisfied here. So I'm just showing you the program right now. Yes, this one. You can see that program here, that contracting L I'm just defining here. Okay, now coming to the this one. And then if length of L is less than 3, why I am writing here like that, I will tell you later. Okay, but if it is like that, then return to true, otherwise that return this condition. So what is the condition? As I already told you, that absolute of L1 minus L0 should be greater than absolute of L2 minus L1, and then there is a recurrence condition. So what is the recurrence condition? The contracting L1 from, and 1 from the last one, from 1 up to the last number of that list. Okay, so this is the recurrence, and I know all of you know about that recurrence. So recurrence condition is nothing but it is just repeating again that you can, if that condition is satisfied, then contracting L1 dot, it will 1 colon, it will go like contracting L, and it will replace L by L1 dot, I mean 1 colon this one, and after that it will again run this program, and if it is again true, then it will come as again 1 dot this one, that means 2 colon that last up to last number. So this type of things will be a recurrence loop, you can say. And what is the what is the importance of that AND, I will also tell you right now. Okay, but before that I am going to just run that program if it is correct or not. So let's see. Yes.
जादू म्हणतो जायचंय का तुला?
Can you please mute yourself? Okay.
जादू विचारतो मॅच सुरू झाली तुला जायचंय का?
Satish, can you please mute yourself? Okay, so from week 3 previous 1 import star, I'm just going to write that, and there what should I write? Yes, so I will write here the list. Let's say I'm just writing here one list, 3, 4, 5, 60, 90. I'm just writing here randomly. Then I'm writing contract. It is showing us false. It should be false, right? Okay, now coming to the true one. Whatever I have written there, I forget that one. I think -2 and then -1 I have written there. Okay. Then right here contracting F. It is showing us true. So that means whatever we want in our question, it is coming like that. So our programming is true and correct. Now coming to the AND question. What is the importance of that AND?
Ma'am,
Yes.
ABS is a predefined function.
Which one?
ABS of
Yes, ABS. Yes. Just like len, len gives the length of that list, right? So
Okay.
just like that, ABS is also a predefined function. It is already given there. Okay.
which gives what num? Length gives the length of the list, number of items in the list. ABS means
ABS is the modulus, I mean that mod value.
Absolute value.
Yes, absolute value.
Without negative
Yes,
values, it will
yes,
give.
yes, yes. If there is, let's say, L1 minus L0 is minus 2, then ABS is giving us plus 2. Like that. Okay, now coming to one thing. So why I have written here length of L less than 3. Let's say I am writing here only 3 and 7. So this is the condition that length of L is less than 3, because here the length of L is 2. Okay, so now I am writing contracting L. It is writing here true. So why I am writing here this one, that this is the last condition. I am doing here recursion in that program. So when the recursion will stop, when this condition will satisfy, that length of L should be less than 3. Because we are in that question, what they are asking about two adjacent pairs should be decreasing. But here you can see this is the simple one, this is the minimum length of that list, so that we can have, if our length will be less than 3, then we can stop our program. Okay, so this is a condition for stopping the program, for termination of that program. So if the length of L is less than 2, then only we can write true and we can stop the program, or otherwise we can do our recurrency question.
If we give in list one item, it is not running,
Sorry?
right? If we give the list of numbers is 1, it is not running, because we have to have 2 items. in the
Yes,
list.
obviously you have to have two
So that
numbers at least.
list of L is less than 3 is working true.
Yeah, so there is a two importance of this. One importance is that the availability of your question. The question says that two adjacent pairs should be strictly decreasing. So for that we need at least 2 value, right? So at least, yes, this is the one thing, and another thing is the termination of that program, when we should terminate our program. So the condition for termination is if our L will be let's say 2 in number, and in that length it is only 2. That means we can now stop our program.
Ma'am, please explain contracting L recurrence. Couldn't get.
Recurrence you don't have. Okay, now then I have to write here explicitly. Let's say I am taking here L equals to 2, not 2, okay, 2, 10, 5, 3. Sorry, 5, 3. This is my length. I mean, this is my L. Okay. So just tell me what will be the value of this one. What will be the value of this?
4.
4. Fine.
4.
At the very first time, I'm just going at the very first one. Now, if that my program will face that condition, if length of L is less than 3, obviously L it is false. For condition is false, right? So condition is false. That means we have to go here. That it is return condition. If it is true, then it will come here. Okay. So it is nothing like that. If I write here else, like that. Right? Okay. So that else, so at the very first time, my if condition is false, so that means I will go here. So what is the meaning of that line? So here, what is that? L1 minus L0. So let's calculate. I'm calculating here. Absolute of L1 minus L0. L1 L0, what will be the value of L1 L0? That 10 minus 2. That means 8. Okay. So, and is it greater than 5 minus 10? I mean that mod of. Is it greater than 5 minus 10 or not? It's greater. Okay. So that means the first condition is satisfied here, and there is another and is there. You know that and is like
So, ma'am,
And both
in
the
our
condition are true, then
Yes,
only it will be.
yes. Both of the conditions will be true. Then only the result will be true. Otherwise, any of the condition will be false. Then it will say as a false statement. Okay. So here and I'm writing here and. So and contracting L. So contracting L means it's a recursion at least. So recursion means what? You can say here L1 dot. So L1 dot means you can tell that my new L is now 10, 5, 3 because I am counting here from 1. That means from here to here. This one. Okay. So
Yes, ma'am, got.
yes. So I am counting from here. So that means my new function is this one. Contracting 10, 5, 3. This is my new L right now after one iteration. Now I have to check that 3 that this L, that new L has also satisfied these whole conditions or not. If it will satisfy, then it will again come in the next iteration, and in the next iteration what will be the L? The next iteration will be like 5, 3. Yes. And then again, let's say I'm just coming here, and after that what will happen? Contracting 5, 3 means on this condition will be satisfied that the length of L less than 0. So that means it will directly come to that one that returns true. Do you get the point that what is the importance
Yes,
of
ma'am.
recurrence? Yes. So
Ma'am, one doubt, ma'am.
yes.
Ma'am, you're saying we are sending contracting 10, 5, 3, no, ma'am. Okay. At that time, when it goes up, length of L will be 3, no, ma'am. 3 less than 3. Condition is false. Okay, ma'am. Okay, ma'am. It's fine. Okay, thank you.
Yes. So 3 is not less than 3. If I am writing here less than equals to, then it will be a problem. Okay, but here I am writing less than 3. So that means it will go to the next iteration. Okay, so I think this program is also understandable. Yes.
Anything else than 3? Can we write 4?
See, we can write 4, but the main condition, what was the condition? The condition was like if I have a list like this type of list, then that adjacent two pairs should be, the difference between the two pairs should be strictly decreasing. So if I write here 4, right, so if I should not do like that if I write here let's say 4, then what will happen? Up to that condition, whenever it will come like in that 4, this one, yes, whenever it will come this one, then it will stop, it will give us a true. But if I write here let's say 30, then it should not be a true value, it should be a false value, right? So up to which length we need, because two adjacent pair I have to calculate. So two adjacent pair, obviously for two adjacent pair I need at least 3 number. So if it is not 3 number, if it is more than 3 number, then our answer should be wrong, because we are just terminating our program up to 3, but we should have our program up to 2 length, so that we can have the correct answer. If I write here let's say 5, then it will calculate only up to 4 length, and after that it will give us a wrong result.
hello, ma'am.
Yes.
Can we write if length L is smaller than equal to 2?
Yes, smaller than equal to 2 is also a good thing. Okay, that is not that much big or trouble. You can write less than equals to 2 also. But yeah, that is thing. And one more thing I want to tell you. If I write here, let's say or. Okay, so is it correct or not?
No, ma'am, not.
No. Contract recursive will not happen. Any one will happen.
Yes. So
Equal to 3 will not work, madam.
Okay.
Equal to 3 because equal to 3 includes two pairs.
Equal
If
to
you are,
Then and equal to 2 will work.
equal to 2 should work, na? Equal to not
if you
3,
have to write
equal to 2.
then 2 will occur only, not 3.
Wait.
Yes, like if I'm writing equals to, then it should be 2. Otherwise, it will give a wrong answer, right?
And not that, in case of 2, not that is less than. Then it should be strictly equal to. And if you are using less than equal to, then it should be 3. It equal, if only less than, then 3. Equal to, then only 2. No other condition.
But let's say in that condition, okay, if I'm writing like that, then if I write only one L, so as you were talking,
Less than 1, that it covers over single atom, single member only.
so single, I mean,
Which is,
it should not be the, it should give a true value. I mean that this one, it should
that will be
terminate.
absurd. That will be absurd. While there is only one member, you are giving 2, that is absurd. That will be absurd.
That is absurd, but let's say someone will give the input as n equals to 4. I mean only one number. Okay, so what should be the answer here?
Less than 3 only, or equal to 2 only.
Okay,
If
okay.
you are writing equal to, then 2 only.
Less than,
Less than 3,
less
then
than
3
equal
only.
to 2
Three
is
is correct.
Okay, just a minute, just a minute. Just a minute.
You change and the sum, you put R.
Just a minute, just a minute. I just want to clear these things. Let's say I'm writing here 3, 4, sorry, whatever, 3, 17, then 35, then contracting. It's true, right? Okay. Now I'm writing here 3, 6, then contracting. True, fine. Then I am writing here only 7. True. I mean, what this is, what
It's
this
not true,
means.
ma'am. Only single element, how can it be?
So only see here only single element. So that means there is nothing to minus. So
Some condition is true or less than 3, whether we are giving single value or
yes,
two value. The
yes.
condition is true.
So now I am
Okay,
writing.
that's right.
Now I am writing like that. Okay.
Okay, ma'am. So to avoid confusion, we can give a message. No difference can be find out.
Yeah, that you can write, right? Yes, that you can write. But as a very simple 2 or 3 line program, I am just writing, so that's why I am writing like that. You can write like that also. Okay, just a minute.
Ma'am, if we do 3, we can compare, no. But it gives 2. 3, 70, 35. We can compare 3 and 70, 70 and 35. 2 comparisons can be done.
Yes, 2. Yes.
But it is true.
Yes, because like we are just hoping that 3, 6 and let's say 0 or something. I mean, which is obviously less than 0. I mean, you can say whatever you want. That is not that much big problem. Let's say I am writing here 4, 3. True. Okay. That's a 5. True. Now what he told us that just write here like that. Okay. Let me clear these things.
Which will be double equal to.
Oh
Not
yes,
single equal
yes,
to.
yes. Sorry, yes. Now let's say L equals to 4, then whatever, then 35. Contracting true, okay. Then L equals to 3, 4. True. Then L equals to 4. See, here it is saying that list and index out of range. Because here that recurrence relation is not holding here, right? Because only one number is there, so that means there is no one. I mean, L4 means it is the position of 0th position, 0 position. So if it is like that, then we should write here less than equals to 2 to recover our problem. Can we get that point or not? Should I go to the next class? Next question?
Yes, ma'am.
Okay. Okay, so the next question. Next question is a very simple one. So in that next question, what it is saying, in a list of integers L, okay, the neighbors of Li are Li minus 1 and Li plus 1. They are the neighbors. Li minus 1 and Li plus 1 are the neighbors of Li. Now, Li is a hill if it is strictly greater than its neighbors, and a valley if it is strictly less than its neighbors. Right? And then write a function, this type of function count HVL, that takes as input a list of integers L and returns a list HCVC, where HC is the number of L's in L and VC is the number of values in L. So can you understand the question? The question is like, let's say I am writing here L. L is anything 2, 5, 9, 11. Okay. So here I am just talking about this one. So what is that L of I? It is L of 1. Right? Because it is 0, 1, 2, 3. 0, 1, 2, 3. So the neighbors are, who are the neighbors? The neighbors is 2 and 9. Okay. So 5 will be hill or valley. What is the condition for that? For hill, the condition will be like 5 should be greater than 2 and 5 should be greater than 9. If these two conditions are satisfied, then 5 will be hill. And we will count 5 as a hill. That means if I write here that HC will be 1 for that case. I am talking only one element right now. Okay. But here you can see that 5 is greater than 2, that is true. But 5 is not greater than 9. So that means 5 is not a hill. And also 5 is not a valley. Why it is not a valley? Because the valley condition is like 5 should be less than 2 and 5 should be less than 9. 5 should be less than 2, it is not correct, but it is correct. But that question told us that these two should be simultaneously correct, so that it will be a valley. Do you got the point? What is the question says? Okay. So if let's say here 1L, I'm talking like 3, 10, 2. This one. So here 10. This 10 will be hill or valley? Can you tell me? Hill.
ma'am.
Yes.
Hill.
This will be hill. So if I write here one program and there as a input I am writing like 3, 10 and 2. Then if I write here that count, what was the name of that function? Count HV. Okay. So the count HV, it will give us hill number and valley number. Okay. So in that case, what will be the answer? The answer will be count HV, hill will be 1 and valley will be 0. Why 0? Because let's say I am talking about this one. This does not have two neighbors, right? It has only one neighbor. This also does not have two neighbors. It has only one neighbor. So we should check all these conditions which has two neighbors. Otherwise, how can we say that okay, with respect to two neighbors, this is the highest one, or with respect to these two neighbors, this is the lowest one. So this in this case 3 and 2 will not be in our work, only 10 will be in our work. And if 10 is like greater than 3 and as well as greater than 2, that means we can say that it is a hill and the value will be 0. Do you got the point?
Ma'am, why value will be 0?
Value will be 1.
Why value will be 1? Because see here
Hill value will be 1. 10 is my hill.
10 is hill, that is fine, but who is the value? There is no value, right?
No, value will be 0.
Yes, so that means if I write here, let's say count HV, then here 1 will be there because I am writing here that hill value, and here let's say value. So that means 1 and 0 will be for that question, for that list. Okay, let's say another example.
And what is the condition for value?
Okay, you can see here that the value condition is like that neighbor Li should be less than Li plus 1, and it is also value condition is this one, that Li should be less than Li plus 1, it is also less than Li minus 1. Okay, this is the condition for value. So let's say I am writing here one example, 1, 5, 10, 2, then minus 1 and 1. So this is the n. Okay, so can you tell me what will be the value of that count HV, this and this? This will be the first space will be for hill, and the second place will be for valley number. So this is the hill number and this is for the valley number.
It will be the hill.
So hill will be how many hill are there? So we can write here the number and we can write here the number of valleys.
Ma'am, valley is 3.
Valley is 3.
2 hill, valley 0.
3 valley, I think.
Can you please tell me how many valleys, hills are there at first? And just tell me who
2
are the
hills.
hills.
2 hills, I
Who
think.
are the hills? Who are
5
the
and 10.
5 and minus 1.
0 hill, 0 valleys.
1 hill, ma'am.
Ma'am, 5 and 10 is the hill.
Okay, just tell me one by one. Just a minute. 5 and 10 is the hill. Someone told me about 5 and 10 is the hill.
Only 10.
Only 10.
10 and minus 1, ma'am.
5
Only-
and minus 1, ma'am.
Okay, so 10 is the hill.
No, ma'am. Hill is 5 and minus 1.
So just tell me.
Right neighbor is greater than.
So how many hills are there in that list? Bas.
Only one, that is 10.
Okay, only one, that is 10.
2,
And
ma'am.
2. Okay, so 10 and
Minus 1.
minus 1. Okay, and how many valley are there?
0 valleys.
0. Okay. So all of you are agree with that?
No, ma'am, you explain, ma'am.
No, you just tell me what will be the value. I mean, as you already understood that question, that what is it is so saying here, so you should know that what will be the value of count HV. Otherwise, if you don't understand what will be the value here, then how can you say that my program is correct or not, right? Okay, just a minute. Let's say 5. Okay, just count about 5. 5 is greater than 1, but 5 is not greater than 10. So that means 5 is nothing, not hill, neither hill, nor valley, right? Then coming to the 10. So 10 is greater than 5 as well as 10 is greater than 2. That means 10 should be a hill. Now coming to 2. 2 is greater than 10.
No, 2 is not.
2 is not greater than minus 1?
2 is greater than minus 1 but less than 10.
Yes, 2 is less than 10 and 2 is greater than minus 1, that means 2 is
We are
nothing.
comparing what?
Right. Then coming to the minus 1. So minus 1 is less than 2.
Less than 2 and less
Minus
than 1.
1 is less than 1. That means minus 1 is a value.
Value.
So that means if I write here count HV, then it will be 1 1. Okay. And then 1 is corresponding to 2 and 1 is corresponding to minus 1. Now coming to that programming part. Okay. Yes. So this is the program. Okay. Just see at first the program. Here I have written count HV.
And small dot, ma'am.
Yes.
Ma'am, minus 1 is
Oh, in that question.
nothing.
Okay. Just a minute. Yes, in that question, right?
Yes, ma'am.
What is the question of yours?
Nothing, I mentioned.
Okay. I mean, do you have any problem with minus 1, right? Obviously, minus 1 is less than 2
No, ma'am, no.
and minus 1 is also less than 1. Okay, so that's why it is a value. Okay, now coming to that programming part. Yes, this is the program. So what is written here? At first, this is the name of that function. Now, what is this? Can you tell me what is this?
Hill count.
Initialization.
From here initializing the value of hills and valley.
Yes.
Initially, it will be 0.
Yes, initialization. This is also initialization. Okay. Now coming to the for loop. So what is the for loop here? I am counting here from 1 to L, length of L minus 1. Length of L in the minus 1 is nothing but the N. I mean up to that one. Because
Ma'am, only length of L will be there now by minus 1. Range also takes value less than 1 upper bound.
no,
Less than.
I see. I will tell you. Just a minute. Let's say here.
Last value don't have 2 neighbors.
So this one as well as this one I have to record. Okay. That 4 and 2 I don't want to bother about these two. Because these 2 and 4 does not have 2 neighbors. So that's why we are taking from 1 to L, length of L minus 1. Do you got?
Ma'am, I'm telling length of L minus 1 is same as length of L. Writing length of L is same as length of L minus 1.
No. See, here what is the length of L? But here
3.
length of L is 3. So what I want to run only for 3. Because only 3 has neighbors. 2 and 4 does not have neighbor, right? So what should I do? From 1 to 3 minus 1. 3 minus 1. That means 2. Right?
The range is starting from 1. So we can use minus 1 to get the number of list items correctly. That is the reason you are taking N minus 1.
See. Here this one is the zeros position, 1 position, 2 position. Position and length has a difference, right? So position,
Yes, ma'am.
yes. So length of L is 3 here. So I am going to run my program from 1 to length of L minus 1. That means 1 to 2. So 1 to 2 means 1 position. Okay, 2, 1 position again. That means only 3 will be calculated here. 2 is not like that I am taking here 4 also. Because up to 2 minus 1 my range will be. So that means 2 minus 1, that means 1th position. Up to 1th position my length will be. So in that case, if I write here 2, 3, 4, that means only 3 value I want to calculate. I mean, I want to worry about only 3. I don't want to worry about 2 and 4. Let's say I am writing here another values 9, 90, like that. Then what will happen? We don't want to bother about 2 and 90. We just want to bother about in between of these, right? So that's why I have written here length of L minus 1. so that I can discard the last one also. Here 1 2 3 4 1 2 3 4 5 6 7 8. Okay, here the number of length of L is 8. 8, right? So what it will do, it will count from 1 to,
Only it will count to 1 to 7, ma'am.
yes.
If we put length 1, actually it gets -1.
No, I can't get your question.
The length of in the list we have 8 items, but when we put length of L, we get 0 to 7 only we can get.
Yeah, no, see, position. Here, range is like position, right? Whatever it is there inside of this is the position. Do you agree on that or not? I mean, one is
I
one.
can understand, ma'am, that.
Yes, one is nothing. One is not a length number. If it,
Ma'am, if we will not -1, then also the program will be right. I'm telling length of L is same as length of L -1. Because
We
range
can
takes
check
value.
in another program, ma'am. Only we put length
okay.
in plain length and in minus length.
Okay. I will do that. Okay, I think people don't understand. Okay, I will do that after completing this one. Okay. Okay. So at first,
No, ma'am. Actually, this is correct one. Length of L -1.
because this is
If we
giving us
write
the, yes.
only length of L, then last
This
member
one will
in the
also be
list
there.
should not have the neighbors.
Yes, I mean it should count 90 also, but we don't want to count that 90 here.
Yes. Up to 9 only we have
Up
to
to 9 we
count.
have to calculate.
If
Otherwise,
we take only length of L, then it will count up to 9. If we take length of L -1, then it will count up to 9.
yes, and if I will write here only length of L, then I will show you that what will be the problem here. Okay, so that you can understand. Okay, so now coming to the program right now. Is it correct or not? Let's check. Otherwise, if it is wrong, then it will be no problem. So, what is that? This one. Import share. Okay. Now I am writing here. Let's say 1L. What was in that? Yes, there. 2, 5, 9, 11. Okay, I am checking 2, 5, 9, 11. 2, 5, 9, 11. Then what was that? Sorry. C. Count HV of L. Is it showing correct? Because we have already told about that question that it should be 0, 0.
Yes, ma'am, the output is correct.
Now coming to the second output, just check if it is running well or not. 1, 5, 10, 2, minus 1, 1. 1, 5, 10, 2, 1, 5, 10, 2, minus 1, 1. Then, fine, because there is one hill and one valley. One hill is 10 and another valley is minus 1. Okay, now coming to the program again.
Suppose 2 hills are there, so it will be passed as 2, 0.
Yes, 2, 0. Let's say I am taking a, can you give me one example where 2 hills will be there? You can tell anything.
Okay, ma'am. 1, 5, 10, 11.
5, 10, 11.
Yeah, up till here. So we'll get 2 hills at least.
No.
11 after 13. ma'am.
1 hill, sir.
13. No. It will be like 1.
Yes, ma'am.
Then it will have a, yes. Now calculate. Okay, just a minute. Why it is like that? Oh yes, 5, yes, sorry. Obviously it should be 1. I made a mistake. It will be 1, so that 10 will be, see, 5 is not a hill, 10 is a hill, and
Madam, any strictly increasing sequence can do with it.
10 is the
now it will have 2 hills. One is 10, another is 4. No, yes, 4. Yes, that's it. Yes, and one hill will be there. Sorry, valley will be there. I'm not talking about valley. I'm just talking about hill right now. See here, the hills are 10 and 4, and the valley is 1. Can you understand?
Yes, ma'am. Thank you, ma'am.
Okay. Just check again, whatever. So now coming to the program again. So here program, in the program, let's say, okay, what is the things here? So there is a if condition. What is the condition here? L of I is greater than L of I minus 1, as well as L of I is greater than L of I plus 1. Why I have put here and? Because obviously and gives us a true result if and only if 2 of the conditions simultaneously will be true. Okay, so that should be like that. So that's why hills equals to hills plus 1. Now coming to the L of I less than Li minus 1 and L of I less than Li plus 1, so that value will be value plus 1. I'm just going to add this value number, and here I'm written here hills and valleys. Okay, so now you can say here, yes, 1 check, right. Now what was the problem there? Like that, right? Okay. Now clear. I'm just going to clear all this. Now let's say L equals to 3, 4, 1. Then count. See, there is a list out of index. Why it is like that? Can you tell me? I have just written here length of L, not length of L minus 1.
Length L minus 1.
Yes? I cannot hear you.
We should use length L minus 1.
No, if I am writing length of L only here, then what will be the problem here? Can you tell me?
It is searching for fourth element, which is not there.
Yes, because there is no element after that. After 1 there is no element, and they are also talking about something I plus 1, right? So I plus 1 we will not be here, taking here, so that's why it is saying that least index out of range. That if condition is already written there clearly, that what is the problem here. Index error is there, and if L of I less than L I minus 1 and L of I less than L I plus 1, then that type of condition will not be here unless I am writing here minus 1. Okay, so I think you all understand this problem.
Yes, ma'am.
Okay. Now we will go to the next problem.
Madam, in this program,
yes,
instead of writing and counting hill and valley, can we print a number? How can we print that number, hill number and valley?
You can tell me that. It's a simple thing. Can you tell me?
And print L of I think.
Just print I. Print I.
Print I.
Yes,
Sorry.
yes, that's a very simple thing. If I want I, then print I, or I mean return I.
position, ma'am. L of I is the list item we can get.
Then L of I will be like there, right?
Yes, ma'am.
Not I. I will give the position only.
Position.
So which position it is, then only that position it will give. If I write L of I, then it will give that number
We
what
can
is
put
present
print
in that
statement
position.
we can put print statement.
Ma'am, we can give return L of I.
Yes, and one more thing, that there should be two print. Like if you want hills and valleys differently, that means you can write here one print, sorry, here one return or print. It should be written, okay, because it's going inside that loop. And here also after that value you can write that this L of I. Do you got that right? Hello. Okay.
Yes, ma'am.
Okay, so now that is a reason.
Ma'am,
Now
please show. Or it will be a homework, ma'am.
you people are not doing any homework. So yes, it should be a homework, right?
Yes, that's
That
Ma'am, I have a question.
Yes.
Ma'am, what is recursive insertion sort that as discussed Mukund sir in his lecture last lecture of week 3.
So what is
In
recursion?
Yes, ma'am. Recursion insertion sort.
Oh, you want three things explanation, like insertion sort and recursion sort, or what?
Yes.
Oh.
Ma'am, insertion sort using recursion.
Okay, insertion sort using recursion. Okay. Okay, I can tell you right now also that one. But I mean, in exactly which position you have problem? Like in his lecture, he was taking up one example. I think, as per I remember, he was talking about one example, that sorting of numbers, right? That latest one, I think you have to sort like that. You have to give the highest marks at the very top of the position and the lowest mark at the very lowest position, and you have to sort out like that. And that type of things we were just talking about with the help of recursion, right? Is it like that? I think the problem. And he was just doing at first the sorting with the two methods. At first, I think I forgot that lecture. What basically you want to know, like how to do that insertion, or what is the physics? I mean, sorry, what is the theory behind that insertion? What you want?
And how to do the insertion?
How to do the insertion? Okay, so
recursion also means.
So how to do the insertion, right? So as he was taking about one example, I'm just taking the same example. Let's say here I have some numbers. What was, and you understand that what is the difference between arrays and list, right? I hope you understand arrays and list.
No, if you can briefly tell.
Okay.
Ma'am, the list which we are using here is same as linked list or different?
Sorry, the list.
Ma'am, linked list, here we are using list in Python. It's same as linked list as we have used in data structure.
No, it's different.
Yes, it's different. But yeah, that is the totally different out of syllabus, right? I mean, I'm right now talking about array and list. So what can you tell me what is the difference between array and list? It is already mentioned in that lecture also, right?
Yes, array contain the same data item, means homogeneous, and list may contain different types of item, maybe string, maybe integer float. I think so.
That is not an important difference. Okay.
The list we can store memory can be taken where it is the space is there. Array is one by one. It
Yeah,
goes.
that is the main difference between array and list. In that array we have to put all the all the numbers or whatever you are going to do there, that there should be no space in between these two space. Okay, there should
My
be no
memory is
space.
already defined
If we insert, we
beforehand.
cannot insert the things. We have to get down the things and we have to
Yes.
insert. So the
Yeah.
memory is wasted, the time is wasted, the usage of memory is wasted. So the disk is overcome that problem.
Yeah, so if we want to add something here, then we have to add like as there is no space in between these two lines, let's say, then we have to add these and a new one after doing these things a little bit down. Okay,
Yes,
and
insertion
after that,
deletion is difficult.
and
Insertion deletion is difficult.
yeah, and after that we can do that. And if we want to delete something from here, then the whole thing will go like, sorry, not here, from here, let's say, then whole thing will go up, so that it will become a continuous array, continuous string, whatever it is. No, not string, but continuous memory, you can say like that. And there should not be any space in between these two lines. It's a very simple definition. And list may have any type of space you want. It may be like here I am putting one number, let's say I am putting, and here I am putting j, but in between that there is a big space. It can be like that in that list. Okay, so now coming to that insertion problem. So insertion problem, in that insertion problem, what was there? Let's say I have some numbers. Where should I write?
Do something for that disturbance.
So insertion, for that insertion short, so the insertion is that there will be start building a sorted sequence with one element. Okay, and what, let's say I have a list of numbers 7, 20, 25 and 30. So this and 1 here. So these 5 numbers I have. So whatever I told the example, that we just want to sort this sequence as a, at the very first will be the highest number and the very last will be the lowest number. So what will be the sequence? The sequence should be like 30, 25, 27 and 1. Right, like that it should be. So but I have that type of things, or I have maybe, let's say, here 20 and here 7, like that. So how do I insert? So insertion sort means I have to write like that, and how to do that. So there will be if the two method is there, one is the selection sort and another is the insertion sort. So the selection sort, you can say, where should I write this? Okay. So insertion sort means I have 1, 27, what was that, 25 and 30. These numbers I have. Now in that selection sort, what we will do, in that selection sort, let's say I am making one sequence, that 1, 27, 25, 30. Now I am just comparing thoroughly that what is the minimum one. Okay, so the minimum one is 1. If it is minimum 1, then it is in that next sequence, it is already defined as 1. And then again I am writing here the same thing. Then from this thing to this. Now I am not going to scan or hold the things. hold the sequence, but I am now going to scan up from 1 up to the last one. So here which one was the minimum, we have to check. The minimum one is 7. So that means the 7 will be replaced by 28 and 28 will be replaced by 7. That means my next sequence will be like 1, 7, 28, 25. Sorry, it is 20, I think. Yes, 20 and then 30. Now what I will do, I will just scan from here to there. So what will be the minimum one? The minimum one is 20. So 20 is again, it is whatever it is there, it is still having the same position. And then again I have to scan these two. Among these two, this one is the minimum, so it is like that. Then I can write 1, 7, 20, 25, 30. So this is the selection sort. Okay. Now coming to the insertion sort. So I have again the number 1, 20, 7, I think 25, 30. These are the numbers. Now what I will do, I will make a new sequence at first. There I'm just scanning all the things. Sorry, I'm just putting the first one, right? Then I'm scanning the same thing again from here to here, and then I'm having that one, that 7 is the lowest one. So I'm putting here. Oh, sorry. Insertion sort is not like that. Sorry. This one. Insertion sort is like, here is a sequence, right? So I am comparing these two. So which one is the lowest one? So if this is the lowest one, then it will be go to the leftmost. So it is the lowest one, so that means it is going to the leftmost position. Then 20. Then 25, 30. Then I am comparing these two. Which one is the lowest one? 7 is the lowest one, so it will go to the leftmost. So now what will be the 1, 7, 20, 25, 30. Then again I have to check among these two which one is the lowest one. The lowest one is 20, so it should be go to the leftmost. So it is itself a leftmost number. So there is nothing change. And then again I have to check that 25 and 30. 25 is the least one, so it should be go to the leftmost. So it is there. So that means we should not be do any type of change here. So this is known as the insertion sort. So here pick up the next sorted element and insert it into its correct place. So next sorted element means I am just pick up the next one and I am just comparing among these two numbers which one is the least one or which one I want to do in the left position. I am putting that in the left position. This is the insertion. I am just picking up one value and I am just inserting that value to the leftmost position. So it is known as the insertion sort. And pick up the next sorted element and insert it into its correct place in the already sorted sequence. That is the thing. So why it is 1 is already sorted and next among 7 and 20, 7 will be the least one and it should be inserted to leftmost. Then 1 and 7 will be the next sequence, sorted second sequence in the next iteration, and the next iteration also 20 among the 20 and 25. 20 will be in that sorted sequence and like that it will go.
Ma'am, recursion, please.
Okay, recursion.
About
Recursion is very simple. Let's say among that, I mean, when you are talking about recursion, obviously in your mind it is coming like factorials of a number or the multiplication of a number, as sir already told in that lecture. So I am talking about only the, let's say, factorization. Okay, so let's say
no ma'am, Fibonacci series.
Okay, Fibonacci, yes.
Fibonacci.
Yes, Fibonacci series is also like that. So what is the Fibonacci series? Fibonacci series is 1, 2, 3, then 5, then 8, something like that. Okay, I think you know that Fibonacci series. Fibonacci series has the property is that this one plus this one it will give this one, and this one plus this one it will give this one, right? Something like that. So that means 1, 2, 3, 5, 8, and what will be the next one? 13. Yes, and the next one will be 21, something like that. So here in the Fibonacci series, what is, we have to mention one base case. So if for each and every recursion condition we have to mention one base case. What is the base case here? The base case will be the first one that I have just mentioned here. Let's say L equals to 1. Okay, I am just remembering that. So this one I have just mentioned, and then what I will do, 1 plus, what I will do here, for getting this one, the 1 plus the next one, right? So 2, that means we are getting the 3, and then the recursion condition, what it will do, it will calculate, let's say I am just write here Fibonacci, sorry, let's say Fib, okay, Fib, okay, Fib L. So Fib L is my function name, let's say, okay. So this is the Fib L. So Fib L has one thing, that Fib L plus one. So what is these things? Like here I, then I plus 1, then I plus 1. Then again this plus this one. Then I plus 1 plus I plus 1. Then again this plus this one. So I am taking the next one and the previous one to have my new one. This is called the recursion. I am just taking previous one and then replaced by that new one is replaced by this one. Now the latest one will be replaced by I plus 1 plus I plus 1 plus I plus 1, because this whole and this one. So my new recursion will be like that one. So each and every time it will calculate the next number and then the previous number and then add that. So this is the recursion. So in that factorial also you can say that n factorial and n into n minus 1 factorial. So n factorial equal to n into n minus 1. That means for calculating n factorial we can calculate n minus 1 factorial. For n minus 1 factorial we can calculate n minus 2 factorial. So that n into n minus 1, n minus 2 factorial. And then dot 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 up to it will be up to 0 factorial. So 0 factorial is nothing but 1. So for factorial case the base case is 1. I mean that 0 factorial is 1. So this will be like that. So the recursion is nothing that it will change the new value with a different number which will calculate the new one. Actual previous one, that to calculate n factorial we have to calculate n minus 1 factorial. So to calculate n minus 1 factorial we can calculate n minus 2 factorial, something like that. Okay, and for the Fibonacci series also, that 1 plus 2 plus 3 is there. So that means the first one is, let's say 1 I, and then I plus 1. Then this one what will be? I plus 1 plus I, because this one plus this one. And the next one will be what? That I plus 1 plus I plus 1. Like that. Okay. So this is the recursion. And okay, so coming to the third question, I think. Can I go to the third question? In the third question, a square n by n matrix is there. Okay, and it is a square n by n matrix of integers, can be written in Python as a list of n elements, where each number is in turn a list of n integers representing a row of the matrix. That n, it is a n by n matrix, so if n equals to 3, let's say, then it is a 3 by 3 matrix, right? Then write a function left rotate m. Left rotate m, what it will do? That takes a list representation m of a square matrix as input and returns the matrix obtained by rotating the original matrix counterclockwise by 90 degrees. Okay, so if this is a M, let's say this is a M, then what will be the left rotated M? Left rotated M, it will do the counterclockwise 90-degree rotation of matrix M. So what is the meaning of that? Let's say 1, 2, 3 is there, 4, 5, 6, 7, 8, 9 is there. Then this 147 will go to as a last 147. And then this 2, 2, 5, 8, it will come as 90-degree rotation. 3, 6, 8, 6, 9, it is coming as like that. Okay. Do you understand the problem? Okay, so the problem as whatever I have written here, that M, and this M should be like that. Counterclockwise 90-degree means that column, that first column will be the last row, the second column will be the second row, third column will be the first row. This is the 90-degree rotation. Okay. So now for that case, I can write a matrix. So in that matrix, let's say I have the matrix here. This one is the matrix. It's a little bit complicated, but I already knew that you people have already known about that matrix calculation and how to write the matrix, how to operate that matrix in week 3 assignment, current assignment. So that's why I am not going to do the details of that. Here you can see that I have just mentioned here the definition of left rotated M. Okay, so this is the function name, and then size of L is nothing but the length of M. Let's say M is like that. Sorry, 1, 2, 3. Sorry, 3, 4. 1, 4, 5. Then 5, 6, 7. Like that. Then what will be the size? The size will be 3, because the length of M is 3, because it's a 3 by 3 matrix. 3 by 3 matrix. Now coming to the rotated M, I have just mentioned here rotated M as a name, and I am just giving the initialization here as a empty set, right? Because this is an empty set. At first the initialization is like that. Then coming to the for loop, in that for loop, I is going from range size, right? So range size is range size. Then what it will do? It will do that from 0, 1, 2, right? Then rotated M append, that means each and every matrix will be added here in that empty list. Each and every number will add here in that empty list, so that we can have a total matrix. Now coming to the column and row exchange, that means as in your example I have shown you that my matrix should be counterclockwise. Yes.
Append list is there, so how it will append, ma'am? No variable is there.
No variable means it will just add the numbers.
Initialization of rotate M.
This is the initialization. This is the empty set. Empty set, yes. So in that empty set, I am writing here this one. So what is this one? This one is nothing but whatever I will write in my M value. That's 2, 3, 3, 1, 4, 5, 5, 6, 7. It will just add there. Okay. And now, so I mean up to line 5, whatever I have written here, it is just nothing but constructing a matrix. Okay, so here I am just constructing each and element inside of that empty matrix, and I am having rotated M. I mean rotated M is the nothing but the name, right? So I am just putting that name in that matrix. Now what I will do, I will just do the counterclockwise rotation 90-degree counterclockwise rotation of column as well as row. As I already mentioned in that question that you can see here, oh sorry, where is the question? Yes, here you can see that first column, whatever it was, it is going to the last row, right? So we have to mention that my condition is like that, so that I can have first column will be the last row.
No, she is asking correct only. You have implied first rotate underscore m equal to empty set. What you are doing in that rotate underscore m dot append?
Ma'am, you just comment for C from there and just show what is the output of rotate underscore ma'am dot append. What will be the output of this?
Okay. This one, fine? Fine, na? Then yes. It is not left side. See, this is a empty thing because I did not do anything here.
Always we have to initialize the matrix before using it.
So here, yes. Hello?
Yes, ma'am. Ma'am, we have to append something to variable I.
No, here they are just mentioning that.
Hello, ma'am.
Yes.
Without the if
I
can be done,
underscore.
What?
Why you use rotated underscore m?
This is a name, okay. I mean, I'm just putting a
variable
name.
Name.
Variable name, yes. This is nothing but other than a variable name. So I have put a variable name here, rotated underscore.
You also use other name here.
This is the initialization, okay. That I mean, this rotated AM will rotate in such a way that it will like that row will be the column, the first row will be the last column, and then that 90-degree rotation, okay. Because you can see here what I have written here.
Underscore is necessary to give there.
Underscore? Okay, you have your problem with underscore.
Yes, ma'am.
If I don't write anything like that, also it is also fine. Like if I write like that, also it is also fine. It is just a name. Okay.
Understand, ma'am.
So sorry. So let's say I'm writing here like that. So it is like at first the C will go from that size -1, -1, -1. What is the meaning of that? Can you tell me? I mean, C size -1, -1, -1.
Jumping from the reverse, it is size -1 means the size is less than other. The range it is less than 1. It comes from the back side.
Ma'am,
so
here, yeah. Ma'am, here what will be the value of size 9 or 3? Length 9? Of M will be what? 3 or 9? Size equal to 3 star 3 means 9.
No. A length of M because M is yes
3 or 9. What will
3,
be
3. So here, see here size -1. So size of -1 means 2, right? 2 and we are going to step of -1. That means 2, then 1, then 0.
0.
Why 0? Because up to -1 I can calculate. It's not minus up to -1. Before -1 I can calculate. So that's why I can calculate 0 also. So now that column is coming from 2, 1, 0, and then row
2, 1, 5, I think, ma'am.
No, 0 will also be there. Because here, what I am writing here, that up to minus 1, minus 1. I mean, see, here it should be like that, but minus 1 will not take. It will take only 0 value. Okay. Okay, now the range, row value. What it will take the row value? Row value will take that size of range. That means 0, 1, 2. 0, 1, 2. Yes. And then rotated size minus C plus 1. Can you tell me what is the meaning of this one? As I have written here. And then append MRC. You can just follow the indentation here so that you can tell that answer.
Rotate 3 minus 2 plus 1.
And obviously that row for loop is inside the column row. Okay. So that means for each and every C.
2.
Yes.
Size means 2. Rotate 2 minus 3. 2 minus 3 it is negative.
Ma'am, you explain, ma'am.
No, see here basically the row for loop is inside the column for loop. Okay, so for each and every column loop I have to have all row loop, right? Then coming to that one here, at first what will be R? Let's say R value will be 0 at first, because R value is 0 to 0, 1, 2. Because if I am writing n equals to 3, then 0, 1, 2 will be the value of R. So at first R equals to 0. Let's check. Then what will be the value of here? Rotated. Then size. Size was what? 3 minus. So rotated 3 minus C. So let's say at first the C value. What
2
will
plus
be the
1.
2.
Yes. So the C value has 2, 1, 0. But for each and every C, I am going to calculate whole value of R. So here at first 2. Then what is the value? Then append 3. Sorry. That M means that matrix, whatever I have written there. Then 3. R. R is what here? 0. Then C. What is the C here? The C here is 2. That means the 0 and 2, the row, 0th row and second column number, 0, 2. Do you understand the matrix representation here? The matrix representation can be written like, let's say, this is the 0th position, that is 0th 1 position, then 0th 2, then 1 0, 1 1, 1 2, 2 1, 2 2, 2, oh sorry, 2 0, 2 1, 2 2. Do you understand what I have written here? This is the position. Okay, 0 0 means that position of that first one is 0 0. In that matrix also I can write here. If I have, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. So that 1 is nothing but that 0 0 element. That means M of 0 0. Whatever written here. RC. So this is M of 0 0. M of 0 0 is 1. Then 2 is M of 0 1. 3 is M of 0 2. Do you understand the thing? that 1, 2, 3, what is the position of this? I mean, what is the meaning of that M00? So that means MRC, this is nothing but the position of that number what we are going to put there. So R, if it is 0, 0, that means at 0, 0 position that element will be, whatever the element will go to that M00 position, that means the first position. That type of things are there. So the first, in that first position it will go. In the second position, what will be the position? 1, 0. Sorry, 0, 1. Because column number is 0 and row number is 1. Okay. So the same like here. At first, it is coming that 0, 2. So whatever the 0th and 2th element was there, now it is going to add in that row. As I already told you what it is doing. It is doing that the first column is totally transferred to the last row. So that means the first column means 0, 0 position was there, and the 0, 0 position will go to, what will be the position of this one? This one position is 2, 0. Okay. So that means 0, 0 position will go to 2, 0 position. That is the main thing of this program.
Will you show please problem statement once again? Full problem statement, complete problem statement.
This problem, okay. The problem is that if I have, I don't have any space, okay. If I have one matrix, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a matrix.
Yeah.
And it is showing that we have to counterclockwise 90-degree rotation of that matrix. That is the meaning of this, that this whole row, whole column 1, 4, 7, it will convert as 1, 4, 7, that last row. Then 2, 5, 8, it will convert as 2, 5, 8. 3, 6, 9, it should convert as 3, 6, 9.
Yes, okay.
Okay, so what is the meaning of this? That 1, 1 at the previous position, at the very previous position, 1, 1 means 0, 0 position was there. So AM of 0, 0 is 1, right? At the previous one, at the very first AM is, AM of 0, 0 is 1. Now my AM of 2, 0 should be 1. Okay? And here that 2 was there. So 2, what was that 2? AM of 0, 1. That one was 2 previously. But now in my program, I should have 2 is nothing but 1, 0. Because this is the 2. So,
yes. Got it. Just I wanted text of that problem statement only.
Okay. Okay. Okay, so this is the case, and then if I write the rotated, then it will come like that. Now coming to the let's save, and then now coming to the problem. I just want to show you the result, is it correct or not. Let's say from week 3 of import dash. Now let's say I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Then what was the left? Left rotate M. See here 1, 2, 1, 4, 7. What was in that first column? It is coming as the last row. 1, 4, 7. Then 2, 5, 8. It is going as 2, 5, 8. 3, 6, 9. It is coming 3, 6, 9. So it has already 90-degree rotated anti-clockwise. Now I can give you a homework if you want to do that. Let's check. I have one matrix M. Okay, now can you calculate, can you just do a matrix? Can you change that matrix with like that matrix? Let's say M prime is the new matrix. So the new matrix is like 2, 5, 8, 3, 6, 9, 1, 4, 7. That means this whole thing will go to here, and this whole thing will go here, and this will go there. Can you do that? It will be your homework so that I can check in next class you can do or not.
We will try.
Yeah, so can you understand the problem? The problem is like that first column will give you the third column, the second column will go to that first column, and the third column will go to the second column. Something like that.
Ma'am, show the previous code, ma'am.
Yes. Oh, sorry. I can give you that program also here in that drive, whatever you have the link, I will upload in that drive all the PPTs as well as the program so that you can have the idea. Okay.
Ma'am, rotate is appending or M is appending, ma'am. Here.
This one is appending that position, that position's number. That is, if R is 0, C is 0, that means 0, 0. 0, 0 positions number what is there, it will append. Or if it is like 0, 1, that means whatever it is in the 0th and 1th position, this number will append in that rotated one. This is the number.
Here that line I can't understand.
Okay. But the time has gone. Okay, we will discuss in next class.
Okay.
But you can just try this
I can try,
calculation.
ma'am.
Okay, this one. Just try again. If it will not be there, then I will tell you in next class.
Ma'am, one program is there, remove duplicate. It is a short program, ma'am. It is there in this means week 2 assignment. Can you explain that little bit?
Which one?
Means remove duplicate. Remove duplicate.
Okay, it is in week 2, I think, right?
Yes, ma'am.
Okay, we will do it next class, right?
Next class, okay, ma'am.
I just want to note down these things. Week 2. Which one? That will remove duplicate, right? Okay. Duplicate. Okay, anything else you want? And okay, this is it, the homework for yours thing. What was that? Yes, this one. This one can be a homework, and the another one homework is like you can write that hills and valley. Which one will be the hill and which one will be the valley? So you can write this one, not the number. You can write the you can print the value of that hill, which one is the hill and which one is the valley. Okay, so these two can be the homework.
I have another doubt in quiz 4 assignment, quiz 4.
Which
can
one?
you explain in the next question? That is regression, concatenation and regression.
Which one? Are you talking about programming or any theory?
Programming.
Okay, programming.
We are having the quiz 1.
Which problem?
In quiz, first problem.
Sorry, I can't hear. Hello?
In quiz, the first problem.
Quiz 1.
No, ma'am, that is 4th quiz, first problem.
4th quiz.
Ma'am, assignment 4. 4th week, assignment 4. Quiz.
So
assignment 4 quiz.
Yes, in that quiz, which question? Like first one, second one, which one?
First, ma'am.
Okay, first quiz. First quiz, you have problem.
No.
So? Hello?
Quiz 4, first question.
Sorry, I can't get it. Can you please tell again?
Ma'am, assignment 4, week 4, question number 1. Quiz 4, question number 1.
Yeah, that I understand. That quiz 4, Question number 1, right?
Yes, ma'am. Regression.
Okay, whatever the question.
Concatenation and regression.
Okay, whatever the question that I don't know, I have to check. So question number 1, week 4 and quiz 4. That is the thing. You have the doubt on that. Okay. As I can tell you right now also, as a fourth assignment has, I think the last date is 23rd. So I can't tell about these things right now, anything. So in the next class we can do about that fourth assignment. Okay.
Yes, ma'am. In next class only I am asking.
Okay. I just want to note it down. Week 4 for quiz question 1. Okay, and one more thing before concluding that session. I want to give you my drive link so that you can have that PPTs also. I have already given this with you people, but okay.
Ma'am, in exam, how the questions will be, ma'am? Options are given, or we have to.
Just a minute, please. Just is this thing? Can you please open this? I'm just sending you. Just check is it working or not. Can you open that link?
Hello, ma'am.
Yes.
In transpose of matrix, row become column and column become row, right?
Yes. Oh yes, I have given one homework also how to make transpose of a matrix. Okay, I think the time has already gone, so you can do this one as also a homework, that how to make a transpose of a matrix. Transpose of a matrix means the column will be row and row will be column.
Yes,
Ma'am, can you please give some hint how the question paper will be in exam on 26th, I think March exam is there. So how the question pattern will be?
Question pattern will be like whatever you are having in that assignment, that there is some quiz as well as the assignment, programming assignment. Okay.
And programming assignment, we have to show the output on computer, we have to run the code.
Yes. And the programming you have to write yourself, and you can just show the compile, run and compile, and you can give the result.
No theory pattern.
Which questions weightage is more programming or quiz?
Which?
Quiz like question.
Sorry, which?
Which question weightage is more assignment question like or quiz like question?
Okay, which one will be more?
Yes.
The more marks.
Yeah. That I don't know. I have to ask sir, because I'm not going to give you the question sheet and all. So I'm not making the question, so I don't know about this. Maybe sir will all tell you about that. But if sir will not tell, then I can tell. I can ask sir, and after that sir will give me the answer. Okay.
Ma'am, the question pattern will be from the same questions which are giving on quiz and assignments, or different?
No, obviously not, na. It should be different, but obviously it's very similar to the questions whatever it is given in that assignment section. Okay.
So we have to be thorough with all this, no, ma'am?
Thorough means, see, I and Arun Prakash, we are explaining the previous year questions. So you have current year question as well as previous year question. So you have much more probability to run through and to understand the programming. So it may be possible that from previous year question some question will come. I don't know, but it may be possible. And also it may be possible that none of these 2 years the questions are coming. It will be something else of that. But it is very similar to that 2 years question. Okay, you can just follow 2 years question, and you can find a very similar of that in the exam.
Thank you, ma'am.
Thank you, ma'am.
Okay, bye.
Thank you, ma'am.
And I can give you, I already give you that link of the drive. So you just follow that drive. In this drive only, you can have all the PPTs and all the programming also. Okay. Bye bye.